We're skipping section 5.4 and going straight to section 5.5, solving trig equations. The first thing you're going to do is isolate the trig function involved, and then you're going to use the techniques from chapter 4 to solve the equation. So let's talk about what that looks like. This would be what you would see on a test. For example, solve the equation 2 sine x equals 1 for somewhere between 0 and 2 pi. Okay, so our equation is 2 sine x equals 1. My first step was to isolate the trig function, so that would be sine of x. So I'm going to divide both sides by 2. And I am left with sine of x equals 1/2. And because this is between 0 and 2 pi, I know that the sine of x equals 1/2. 2 places, okay, so I should have 2 answers. So this is where y equals 1/2 on the unit circle. And that happens at pi over 6 and 5 pi over 6. In our next example, we're going to look at another strategy, okay, for isolating the variable. In this case, I have sine of x twice in my equation, so I'm going to want to collect like terms. If you thought of this as just being an x instead of a sine of x, that may help, okay? So this is the sine of x plus the square root of 2 equals negative sine of x. All right, so in order to combine like terms, I'm going to leave the square root of 2 where it is. So in order to do that, I need to move this sine of x, and then I need to do the same thing to both sides of my equation, and I am left with the square root of 2 equals negative 2 sine of x. When I divide both sides by negative 2, I now have negative root 2 over 2 equals the sine of x. So this is now what I'm going to be looking for as my y value on the unit circle because I'm looking at sine. And I'm going to be looking between 0 and 2 pi. Root 2 over 2 are my 45-degree angles, and sine of x is negative in quadrants 3 and 4. So that is going to be my angles of 5 pi over 4 and 7 pi over 4. In the next example, we're going to look at a case where there is something squared on my trig function. So again, we're going to start with our equation. 3 tangent squared x minus 1 equals 0. Again, if we thought of this as an x squared instead of a tangent squared x, our first thing we would want to do is add 1 to both sides. So we have 3 tangent squared x equals 1. And then I'm going to divide by 3. So I get that the tangent square root of x equals 1/3. So tangent of x is the square root of 1 over 3. And this could be either the positive or the negative. Okay, so we're actually going to end up with 4 values, okay, between 0 and 2 pi. So let's look at what that means. So for tangent to come out to be 1 over root 3, because the square root of 1 is 1, so this means that y was 1/2 and x is root 3 over 2. So when I take 1/2 divided by root 3 over 2, those 2's cancel. And this is going to happen when that's plus or minus, and this is plus or minus. The 4 places that happen are 5 pi over 6, pi over 6, 7 pi over 6, and 11 pi over 6. Another strategy is factoring. We can factor things that are quadratics or not. Example 4 is not a quadratic. So our equation is cotangent of x cosine squared x equals 2 cotangent x. Now in this case, you may be able to actually see that the cotangent of x cosine squared x equals 2 cotangent x. Really, those two are going to come out of both sides. But what that leaves us with is that the cosine squared of x equals 2, or that the cosine of x equals the square root of 2. But that is not in the domain of the cosine of x. That can't happen. So we're going to have to solve this for cotangent of x instead of for the cosine of x. Well, how do I get rid of the cosine? Well, I can start over. And then I'm going to set it equal to 0. So I'm going to subtract 2 times the cotangent of x from both sides. And then the right-hand side becomes 0. Now I can factor out the cotangent of x to get the cosine squared x minus 2 equals 0. Divide both sides by all that stuff in the parentheses, and I am left with the cotangent of x equals 0. Now that is on the unit circle. Cotangent is x over y, so this means that my x is 0 and my y is either positive or negative 1. This happens twice on the unit circle, at pi over 2 and 3 pi over 2. In our next example, we have a sine squared on one side, and we have just a sine term. We can't combine those into like terms since they're added, they're not multiplied. So let's rearrange this to equal 0. I have 2 sine squared x. I subtract sine of x from both sides and then subtract the 1 to be equal to 0. And now I have something that looks like a quadratic equation. If you think of this as 2x squared minus x minus 1 equals 0, well, this one becomes a little bit easier to factor. Hopefully you remember how to factor a quadratic, so I'm going to go over that relatively quickly. So I do know that I'm going to have 2 in one of these and 1 in the other, but instead of being x, it is sine of x. That's really the only difference. And then I'm going to have one of them be positive and one of them be negative. And I'm going to have 1 here, and then I just have to figure out which one's positive and which one's negative. The negative sign wins, so it's going to go opposite the larger coefficient, and that one's plus. And now I have 2 different things that I can set equal to 0. So either 2 sine of x plus 1 equals 0, so the sine of x equals negative 1/2, or the sine of x minus 1 equals 0, so sine of x equals 1. So these happen at 3 different places because sine of x equals 1 only happens once. Sine of x is negative 1/2 at 7 pi over 6 and 11 pi over 6, and then sine of x equals 1 at pi over 2. So those are my 3 possible answers. Our next strategy is going to be used when we have 2 different trig functions. In this case, we're going to want to replace one of them in order to basically solve with a single trig function like we've already done. So here, the sine squared of x is 1 minus cosine squared x, and I have cosine here, so I'm going to replace that. So I get 2 times 1 minus cosine squared x plus 3 cosine x minus 3. equals 0. I'm going to distribute my 2. I have 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. And then I'm going to put this in a more familiar looking form, so ax squared plus bx plus c, but it's a negative 2 cosine squared x plus 3 cosine x, and then negative 3 plus 2 is still a negative 1, but we really don't like these negatives out here when we factor, so I'm going to divide the entire equation by negative 1, which means that I will rewrite this as 2 cosine squared x minus 3 cosine x plus 1, and 0 divided by negative 1 is still 0. Alright, so this may look a little bit like 2x squared minus 3x plus 1. So when I factor that, it is 2x and x, and then I have minus 1 and minus 1. If I replace those with my cosine of x, then I get 2 cosine x minus 1 and cosine x minus 1 equals 0. So for this one, cosine is going to equal positive 1, because I'm going to set that equal to 0. I add 1 to both sides, 1 over 2. And then for this one, if the cosine of x minus 1 equals 0, then the cosine of x equals 1. So this happens at pi over 3 and at 5 pi over 3. And then the cosine of x equals 1 at 0 or 2 pi. We're going to start our next and last example with a similar strategy. We're going to replace secant squared x with 1 plus tangent squared x. And so I can rewrite this as 1 plus tangent squared x minus 2 tangent of x minus 4 equals 0. I'm going to rearrange all of that. I have tangent squared x minus 2 tangent of x. 1 minus 4 is negative 3. And then that's all equal to 0. We could think of this as an x squared minus 2x minus 3 equal to 0, which when I factor that becomes x minus 3, x plus 1 equals 0. Replacing those with tangent gives me tangent minus 3, tangent plus 1 equal to 0. In this case, if the tangent of x equals 3, well, that's not on the unit circle. So this is where our final strategy comes into play. We may have to use the inverse tangent. So x is going to be the inverse tangent of 3. You'll have to put this in the calculator. And that happens at 71.6 degrees. In our other scenario, where the tangent of x equals negative 1, this is on the unit circle, and that happens when y over x equals negative 1. So that's negative 1 over 1. So both y and x are 1. That's going to be my 45-degree angles where the sides are equal. It is negative, so it happens in quadrants 2 and 4, which means that those angles are 3 pi over 4 and 7 pi over 4.